So what we're going to do now is some more tidying up on this code. So one of the things that makes it that we need to get used to working with if we're going to use the inbuilt differential equation solver in Python is, instead of defining separate variables for each sort of quantity in the system that we're modeling, so volume in A, volume in B, volume in C, volume in D, we sort of put this into a single object or vector. So if you like, you're used to you should have seen or may vaguely recall, if you have like an X and Y coordinate, you can store those in a vector, right? So a vector of values is a set of quantities, okay? So we can store these four quantities as one sort of vector, which we'll call X. So if we were to store the vector as a list, we just call it like this. So VA, VB, VC, VD. Okay. So now X naught is VA. So where I've put VA here, I'm going to be talking about X naught. So I'm going to move through my code and try and replace it with X and index. If I need one element of X, I'll call it out here. Right, so now get derivatives. So instead of my variable list, I'm just going to pass it X. So now here, what I like, it's up to you. You can change VA to X0 all the way through, but if you're trying to relate this to some system you've got where this is an actual chemical, I actually like to convert sort of my values in X to some named quantities which actually relate to the system. So when I look at my rate equations, I can actually match that up to a diagram I might have drawn out by hand. Okay, so I actually like to sort of leave this as it is, but when I say return RA, I'm going to just say dx dt equals this, return dx dt. Okay, so the derivative of each, so dx by dt is now a vector of the four individual rates or derivatives. So here again, the current values are going to just be in my X vector. Now here, let's see if we can tidy this up. So now we've got X, dx dt, X. So this we can see is a bit of a repetition, so I could say for xi in X, so for each element in X, and I'm saying xi next equals xi plus. So here you see I'm not just going through xi, I also need to go through this, so I need to go for I in range length of X. Okay, so what I'm essentially saying is count the number of elements in X and then give me an index which is going to go through all those elements. So in this case the length of X is 4, so I'm going to go from I 0, 1, 2, 3, which takes me through all the elements. So now to get xi next, I'm actually going to say x plus dx dt, so that's the rate for that one, times the step size. Okay, and now what I can actually do in this case is just replace. So I can say what was in x, find the next value, which is xi plus this. Now I have to be a bit careful because the derivative depends on the current value of this, so I can't overwrite my current value until I know I'm not going to use it again. But in this case, I've calculated my derivatives here, so now I'm going to replace it. And then I can say return xi. So now I'm going to say x0 equals va0 0 0. Let's keep this here. So again, when I come back to change my code, I can sort of come to review it. I can change things that are actually related to the names, so I don't have to work out, oh, x1 must be this, you know. So x at t equals 0, x0. Now my recorded A, B, C, and D, I'm going to leave those as they are. But what I can do is I can store those in an array. So I can say recorded records equals recorded A, recorded B. So you'll see how we can make this much easier using a numpy array. The records is that. So first of all, we've just got x. We can now say x equals x0. Now we have to be a bit careful, because if you remember, when we set numbers to be equal to other numbers, that's alright. When we set lists to be equal to other list, it's a good idea to clone them, so any change we make to x doesn't get reflected in x0. So x equals x0. So then I'm going to say, I'm going to loop over x and store it into my record. So remember to loop over everything in x. I can say records I. So this is like, so the first one is I is 0, so I'm going to say recorded A dot append. Then I'm going to say x I, which is VA current. So essentially this loop just does everything in there, and again when I come to here I can just do it with this loop. Okay, so my code's starting to get a bit neater here. This is going to be x. So here, this is where it's a bit dodgy coding, that I'm overwriting my list I've passed into this step. So really, because I'm overwriting it, I don't need to return it. So what I might do is say x next equals a clone of what's in x. Then I'll say x next is that and return the next. Okay, so, and here I'm going to emphasize what my code's doing. Okay, by calling it x next again. So you range, maybe I'll just say n equals len x. Just call all these n's, or n var. Save myself from measuring it all the time. Right, now let's see. So what have I changed? I think I've changed x all the way through. Right, so now if I've done that consistently, let's save this as a different code. BAFTA model v2. Save. Run. Step size not found. 45. So I accidentally put that back. Run it. Records I dot append x next I. So let's try and work out what went wrong there. 85 records equals this. Records I dot append x I. X equals x0 nvar. Let's go print nvar. Debug that, see what, let's check I've got that. So 4, that's right, so it's in this one. So x next equals step model x. So it's saying step model is returning me something that might not be a vector. X next I, so that should just be x next. Just right, let's run that again. Seem to do something. Problem. We've got 1, we've got 0, nothing in between. So somehow I've broken my code. And it looks like it's in this get derivatives. So dx by dt, get derivatives, return dx by dt. So what I could do is just print what is in dx by dt. So that's in my step, get derivatives, print dx dt. Okay, so I'm doing this for 1,000 steps, so let's just decrease the number of steps so I don't print out too much stuff. So let's just run it over 15 and let's run it in times. Run it over a short amount of time. You can see the rates look a bit dodgy. Let's increase the time, see if they change. No, so my rates are essentially out of A into B. So that's right at the start, but what's happening is my X aren't being updated. So right, so I've not then said, here we go, X equals X next. So I've not overloaded, I've not incremented my model. So X next compared to here, X here. Right, save and run. Let's see if that fixes it. Yep, so I'm now getting changing rates in here. So So that was my problem. So I can delete that print statement and this one. And I can return the time. Maybe I can leave the step size. Okay, so now again that was the that was the expected behavior. So what you can see now, or one more shortcut, if I just say plot T against records. So remember, records is a list of my full lists. Let's see what happens. So I run it, X and Y must have the same first dimension. Okay, so it didn't work.